Hey everybody, we are starting a new chapter, chapter 16 on solutions. So what we need to do is talk about what a solution is. We defined it earlier in our notes, but we're going to go back and look at a couple key things about what a solution is. So let's start. Solution is a type of mixture. So we're going to review the types of mixtures. The definition for a mixture is a physical blend of two or more substances. Physical means they can be separated. So it's not a chemical change they're undergoing, they're just physically blended together. Two types of mixtures: homogeneous, homo meaning the same, so mixtures that are uniform. And a solution is an example of a homogeneous mixture. Okay, so solutions are uniform. Most reagents we use in chemistry are solutions, and specifically it's usually water-based solutions. So water mixed with something else. These particles inside a solution are too small to see, so they look transparent. Some good examples: salt water. So when we dissolve salt in water, it completely dissolves. Sugar water, it completely dissolves. It's transparent. You can't see the molecules anymore. Kool-Aid, even though it's red, it is still transparent, or blue or green or whatever flavor you have. Heterogeneous, hetero meaning different, is not uniform throughout. And there's a couple types that we need to talk about that we haven't talked about before. So a colloid is the first kind. These are mixtures whose particles don't settle out. They have large particles, but they don't settle out. So their particles are between 1 nanometer to 100 nanometers. So that's still really, really small. Like you wouldn't see a particle, but it's enough to scatter light, which we're going to talk about. Can be made up of different phases, so solid and liquid, or some other mixture that's the most common is like a liquid with some tiny, tiny solids suspended in it. Look homogeneous but are not. So they look like a solution. Okay, so just by looking at it, you might not necessarily know for sure if it is a colloid or not until you do a specific test. So sometimes they look homogeneous but they're not. Examples: milk, mayo, and cloudy water. So milk has little droplets of fat and protein suspended in it. It looks uniform, right? If it's chunky, then you know it's gone bad. But usually good fresh milk looks uniform. But the fact that it's opaque, which means it has that white cloudy color, means that you're seeing particles. That substance is scattering light. And I'll show some pictures of what I mean. Mayo is the same thing. We have fat mixed with water, and the egg inside of mayo makes, it's called an emulsifier, makes it mix, but those are still little droplets of oil and fat inside there. So let's take a look then at the next type. That's colloids. Oh, and here's my picture of milk. That opaque color, so it's not transparent, it's opaque. And the next type of heterogeneous mixture we need to know is a suspension. These are mixtures whose particles will settle out. So large particle size, denser than water. Dirt and water is a good example. So if, let's say, we took some water in a jar, we shook it up, and we mix it all together, it might look uniform for a little bit, but then we set it on a desk and we let it settle back out. What's going to happen is it's going to slowly settle out until we have all the sediment on the bottom. The reason it settles out is because that sediment, those particles, are denser than water. All right, so this is what we call a suspension. Right? It settles out. Those particles settle out. It's heterogeneous because they're not uniform. And how do we tell if it's a colloid or a suspension or a solution? To do that, we use what's called the Tyndall effect. So this occurs when particles are too small to see with the naked eye, but are large enough to scatter light. This scattering of light is called the Tyndall effect and allows us to identify solutions from colloids. I'm going to show you a picture in a couple seconds. I'll give you a second to start writing it down. Remember, you can always pause the video if you need to. But the Tyndall effect is that opaqueness. So if you see like milk, if you shine a light through it, it's going to block some of that light. Okay, it's going to scatter some of that light. A suspension won't. Maybe the top wouldn't scatter light if it's settled enough, but we know like if we have it mixed up, parts of it would scatter light. So here's some examples. This first picture up here, here's the light source, okay, like a light bulb. This would be a true solution, does not scatter light. You can't, like you can sort of see a shadow of it, but for the most part, you can't see the path of that light. We look, a colloid scatters light. So if you see, you can see really clearly the path of that light going through that mixture. This one's a nice one too. So here would be a pure solution. There's some reflection of the water on the glass, but overall you can't see the path of that light. But when it gets through the solution and hits the colloid, which would be this opaque one over here, it scatters light. So it tends to glow. Colloids tend to glow. So if you ever seen any kind of glowing liquid, I know they make some with like highlighters and stuff, but they scatter light because they're colloids. Their particles are just large enough to scatter that light. So that's it for today. Just a quick overview of the different types of compounds. We are going to be going into lab next class and taking a look at these types. So solutions, suspensions, and colloids. All right, see you in class.